Hello and welcome to the Blum-Novotest GmbH Tech Talk Online. In today's edition, we are going to take a look at the topic of measurement components for digitization in the automotive industry. My name is Johnny Reason. I have been with Blum-Novotest for 11 years now and I work in international sales. My job is to look after our US branch. I am also a global key account manager for the automotive industry. Today, my colleague Marcus Pushman and I have the pleasure of talking to you.
A warm welcome from me too. My name is Marcus Pushman and I have been working for Blum-Novotest for 17 years. As a key account manager, I look after our European automotive customers. Now we will give you a brief overview of today's topics and applications for the digitization of measurement results.
In this Tech Talk Online, we would like to give you a little insight into the typical applications in the automotive industry, in which our products are used. To do so, we will give you a glimpse into applications and processes on the basis of our product diversity. Blum-Novotest has 3 business divisions. Today we will be focusing on the measurement components division, but Blum-Novotest offers much more than that, taking the divisions of measurement machines and Novotest test bench construction into account. So, with the products we manufacture across all business units, we are able to cover the entire spectrum in modern-day production lines, from in-process and post-process test benches, to end-of-line test benches. All 3 divisions work closely together. This means that we also manufacture products that require input and expertise from all business divisions, such as our spindle test benches. You will learn more about this later. Until a few years ago, combustion engines were the only engines being produced. The trend has changed. More and more is being invested in renewable energies, and production lines that have been commonplace up to now are undergoing a transformation. With the onset of renewable energies, we not only see that components have changed, we also see that the number of components has been minimized. If we take the combustion engine as an example, around 1,700 components are required for the drivetrain. If we compare this with the drivetrain in an electric motor, which only has around 100 components, we quickly see that new technology goes hand in hand with a reduction in the number of components on processing lines. This trend makes it exponentially important to establish flexibility in manufacturing processes. This transition towards flexibility involves the creation of self-verifying processes where machines adapt to conditions independently and without the intervention of employees in order to produce dimensionally accurate workpieces. Automatic process monitoring is only possible if sensors that provide information about the workpieces and the tools in the production process are incorporated into the machine. In order to create a closed production loop, it is not only important to store and evaluate the data collected, but also to link intelligent systems to each other. In the following slides we would like to give you some insight into the ways in which Blum products can be beneficial for your production system.
We've now come to the first area of application, and that is concentricity monitoring of tools. Blum offers 2 different products for detecting concentricity faults in a tool prior to machining. Firstly, the fast, high-precision LC50 Digilog laser, shown on the left, and, as a cost-effective and easily retrofittable alternative, the Z-Nano, shown on the right. It is often the case that a chip gets jammed between the tool holder and the spindle, or that a spindle reaches the end of its life. The LC50 Digilog laser can detect a concentricity fault in the mu range within 1.5 seconds. After the concentricity fault has been detected, the tool is locked or the NC program requests a new automatic taper cleaning process. The detected concentricity fault can be displayed graphically on the machine monitor, and saved for documentation purposes. In the video you can see a double spindle machine with a setup consisting of 2 Blum lasers. The concentricity test on the 2 reamers is carried out during the testing process with the coolant switched off. The trailing coolant or the existing coolant mist have no impact on the measurement result. Alternatively, concentricity faults can also be detected tactilely using the Z-Nano probe. Blum offers the system in tethered form, as well as with infrared or radio transmission. The probe can check the concentricity on any smooth surface of the tool. The inspection time for a tool is similar to the LC50 Digilog laser measurement system, at approximately 1.5 seconds and a concentricity greater than 10 μ. As can be seen in the image on the left, the measured value is generated in a similar way to the laser measurement system, without any contact. The Z-Nano is very easy for the operator to use and can be retrofitted to almost any machine at a low cost. In the following video you can see a concentricity monitoring procedure for a tool holder being carried out under real conditions. You may now be asking yourself why coolant is being used during the measurement procedure. Firstly, the system is protected according to IP68, and secondly, chips are cleaned off the measuring surface as a result, thus eliminating the occurrence of pseudo-errors. But the LC50 Digilog laser measurement system can do much more than just check concentricity. With this in mind, we will show you some innovations relating to digitization and visualization in the following section.
Often, simply measuring and monitoring the workpieces and tools is not sufficient. Instead, it is becoming increasingly important to record the data captured and analyze it in more detail. For example, we use the LC Vision software for tool measurement and monitoring. This not only provides a visualization of the measurement results for the laser measurement system, but all necessary data is stored, evaluated and then graphically displayed as well. Intelligent evaluation functions further improve the processing quality. In the next section we would like to show you what Blum-Novotest can offer you with regard to the LC Vision software. Even the standard version of LC Vision can display inputs and outputs graphically. These can be operated quickly and easily on the control screen itself, for example to test the blow nozzle or to view the degree of soiling on the shutters. In addition, the installed components are listed in the serial number management system. With the standard functions alone, LC Vision offers huge production-related benefits, among other things because the machine no longer has to be switched off to determine the status of the laser system. Maintenance work can also be planned over the long term, meaning unplanned maintenance and production downtimes are largely eliminated. With its expandable cycles such as 3D tool control, LC Vision offers a new form of technology. The image shows an example that is reflective of a radius measurement on an 8-bladed tool. On the graphs you can see the respective blades including their penetration angle and length of each blade. In addition, the difference between the longest and shortest blade is also indicated. As such, the single blade analysis also detects a break or wear, as shown here in the magenta-colored area in the image. With the determined data, the surface quality can also be guaranteed with a high degree of process reliability and a sister tool can be used before even more blades wear out due to the greater force influence. The data obtained helps to optimize the production process and increase tool life. All data obtained is recorded and can be viewed in a historical data analysis. The export function allows you to use this data as desired and to evaluate it in more detail. This enables you to optimize projects and increase tool life. The statistics obtained also enable better planning of preventive maintenance, as possible vulnerabilities become visible more quickly. All of the analyses presented thus far are from the LC50 Digilog, which, in an ideal world, would already be integrated into the machine. However, if this is not the case, we also have a solution for you. Which brings us to the PSC. PSC stands for Portable Spindle Control and is a mobile and therefore flexible solution that can be used for all machines in the production process. The PSC also includes our LC Vision software. However, this is not displayed on the control screen itself as with the permanently installed solution. Instead, the software runs on any laptop or PC. The PSC case contains the complete system with all necessary components and can be used immediately as a plug-and-play solution. This system is entirely control independent and can be implemented with the safety door closed while observing the safety precautions. With this adaptable solution, The laser is positioned on the machine table using the magnets, then the LC50 Digilog is connected to the interface in the case and the laptop using the connection and ribbon cables. The advantages of this adaptable solution are the versatile evaluation options, which reflect the spindle and thus the machine status. For example, you can carry out a stability analysis. This determines the point in time at which the machine runs stably under thermal conditions, thereby optimizing machine downtimes. A concentricity check can be carried out over the entire speed range, and a vibration analysis can be performed as well. By using the PSC, processes are optimized and unplanned machine downtimes are minimized. This system can also be used, for example, after a crash or in the event of surface changes to the component to check whether the spindle is still okay. In the following video you can observe a concentricity check that is carried out for entire speed spectrum of the machine. Here, the reference tool is positioned in the laser beam first of all, then the speed is gradually increased. The laser determines the dynamic change in the reference tool at the selected speeds. If deflections are visible, this could be an indication of a defective ball bearing in the spindle. As we mentioned at the outset, all three business areas work closely together, and this is also evident in the spindle analysis. In this respect, we have already come across machine-integrated solutions in the form of our LC50 Digilog laser measurement systems. In addition, with the SE100 end-of-line spindle test bench and the SL100 laboratory test bench, we can offer further solutions for guaranteeing the quality of the motor spindles. For example, the SE100 is especially suitable for series production to ensure the quality of the spindles. The laboratory test stand is specially designed for machine manufacturers, as it provides sensors and evaluation options for optimizing spindle quality. Of course, the topic of digitization does not end with our tool measurement instruments. In the next few slides we will show you digitized solutions on the workpiece.
I will now take the liberty of getting straight down to the tools and workpiece probes themselves. In series production, Blum's measurement systems are characterized above all else by very high process reliability and measuring speed. They are available with both infrared and radio transmission. In highly dynamic machines, the use of measurement systems with radio transmission has become increasingly popular in recent years. You can operate up to 6 different measurement systems with the RC66 radio receiver from Blum. If the machine is already equipped with a receiver, the system can be easily expanded with additional measurement systems at a later date, for example following a conversion to a new component. A probe such as the TC60 is typically used for zeroing and measuring workpieces. Thanks to BRC radio transmission, simultaneous measurement in twin mode is also possible on double spindle machines. The TC64 Digilog is used for scanning and monitoring any contours, but more on that later. The BG series includes machine-independent bore gauges for determining internal diameters greater than 3 mm, the RG roughness testing device with visualization and evaluation on the machine control system, the complex fine spindle tool. This is set to the required dimension by the RC66 receiver after determining the diameter using a probe or bore gauge. The Z-Nano can be used for tool length measurement, monitoring and concentricity testing. The MG80 is used to determine the workpiece temperature and the clamping pressure in real time. Here you can see 2 wireless TC60 probes in twin operation, that means time parallel measurement. Like all Blum measurement components, the probes are protected according to IP68, which means that they can also be operated with coolant present. By using coolant to clean the measuring surface, a significantly higher process reliability is ensured. In the following video you can see a probe that has been specially designed for special purpose applications. The TC6330 probe is a modular system that can be custom-tailored for customer-specific measurement tasks. As you can see, the probe has a carbon extension attached so it can reach deep measuring points. We will explain the advantages of a fast probe in the few next slides.
Thank you, Marcus. Let's look at a real-life case and calculate possible savings for you. As we have already seen, all our products offer great benefits when it comes to manufacturing. Significant savings are also generated through the use of suitable measurement technology. We would like to show you an example of this using an ROI and our probe. In this case study, the customer has a total cycle time of 450 seconds per component. Of this, 45 seconds are taken up by keying time. This has been reduced to 30 seconds thanks to the use of our probe. But what difference does a time saving of 15 seconds per component make in production? Let's assume that we have a normal 3-shift pattern, where production takes place for 20 hours a day, 240 days a year. Let's also assume for the purposes of this example that machine costs are €100, employee costs €40 and work piece costs €50. Now let's work it all out. Due to the time saving of 15 seconds per component, it is possible to produce one additional component every 3.5 hours. With a component value of €50, this results in a saving of €276 per day and thus €66,207 per year per machine. Added to that are the savings in production costs. In this case, the 15 seconds saved result in a saving of 2,400 seconds per day and thus 160 hours per year. Multiplying the time saved by the employee and machine costs results in a total saving of €22,400 per year. If we now combine both results, we arrive at a saving of €7,384 per month and €88,607 per year. These are the results for one machine. Based on this data, it is clear that the break-even point is reached fairly quickly when our products are used. However, cycle time savings are not only generated by probes. With our BGs, we also have systems in our product portfolio that can be used to measure diameters very quickly and with the utmost precision. Which brings us on to the next section.
Let's now turn to the topic of digitized diameter measurement. The fastest and most precise way to measure the diameter of a borehole is with our BG systems. A bore gauge is a machine-independent measurement system that is custom-made. The system is located in the tool magazine like a tool and is inserted into the machine spindle, for example, for a 100% check. One reason why you would opt to use a bore gauge is the measurement time. BGs require only a fraction of the measurement time that a switching probe takes. Another benefit is the fact that measured values are generated in a machine-independent way. Shown here is a BG60 bore gauge that measures the inside diameter of 2-cylinder bores in 2 planes. As with the TC series, a twin measurement, which means time parallel measurement with a bore gauge and double spindles, is also possible in this case. Our products can be used both within the machine tool and outside the machine. The following video shows an adaptable application involving a BG60 on a robot. This measures important bore diameters on a cylinder head. Using modern software, the measurement results can be transferred easily to the machine. The bore gauges also feature evaluation software. Blum offers its BG Vision software for this purpose. Similar to the LC Vision software, the measurement results can be displayed graphically and saved in various formats. In this screenshot you can see a graphical representation of the target dimension, actual dimension, tolerance limits and warning limits as an example. You can call up the overview of the measurement results individually on the control screen of the machine or on an external monitor. As can be seen from the red bar at the very top, a machine alarm is triggered when the tolerance limits are exceeded. Statistical evaluation is also possible using BG Vision, meaning that the measured values can be passed on to a QDOS interface for data storage, for example. The K-field assignment is made here according to the customer specifications. Other formats such as Minitab can also be used. Let's move on to the last part of today's Tech Talk. If complex contours need to be measured or monitored in machine tools, one option is to carry out the check by way of scanning measurement. Blum has a special probe systems for this purpose, such as the digital analog probe TC64 Digilog. The probe can be used to monitor any workpiece contour. The TC64 Digilog needs be taught once at the outset on a good contour. The warning limit as well as the lower and upper tolerance limits are determined on the basis of the good contour. The measured contour is recorded and logged on the control monitor. Some automotive customers use the TC64 Digilog, for example, as a valve seat scanner, as shown here in cylinder head production. The analog probe checks the valve seat for any machining faults that may have occurred, resulting, for example, in microcracks on the tool. If the actual contour produced deviates from the taught target contour, then the TC64 Digilog starts a repeat run in order to prevent pseudo-errors. If a tolerance is exceeded again, the system triggers a hard machine alarm and the valve seat tool will need to be checked. Monitoring the surface quality of the manufactured workpieces is another challenge faced in series production. Blum has a solution for this. With the aid of the RG roughness gauge, the roughness of a machined surface can be assessed automatically in the machine. The video shows the assessment process for a steering knuckle. In this process, the stylus makes contact with the contour and the surface roughness is determined at a predefined scanning speed.
In conclusion, let's summarize the points we've addressed. The LC50 Digilog is used regularly in production processes to monitor tools. The flexible portable spindle control also uses the LC50 laser measurement system to analyze motor spindles and is therefore highly precise. The data determined by the laser is displayed graphically using the innovative LC Vision evaluation and visualization software. Tactile tool measurement systems, such as the Z Nano Tool Probe, provides another way of monitoring tools. These can be retrofitted into the machine in a cost-effective and adaptable manner. In addition to the standard probes, our all-rounders for workpiece measurement also include the modular systems. The motto here is, the ideal solution for every task. The speed advantages provided by the probes also apply to the bore gauges. In this case, too, the diameter is measured quickly and with the utmost precision. Similar to the LC Vision software, the BG Vision software is used to graphically display the data obtained from the bore gauges. Digilog probes are used for machine-integrated inspection of surfaces and geometries. With our scanning Digilog probes, a machine geometry is compared with a taught geometry. The Digilog RGs are used for automated surface inspection during the initial clamping process. In both cases, analog values are generated and displayed on the control screen in a digitized manner.
As you can see, Blum-Novotest is a company that produces both hardware and software. With the versatile product portfolio from our 3 business divisions, we are perfectly set up to be your competent business partner. We would be delighted to provide you with support with your operational processes. We are ready and willing to assist you if you are interested. You can find our contact details below the video. Thank you for your interest and see you next time.
I would also like to say a big thank you for watching. I hope you came across something that piqued your interest. Take care. See you next time.